Okay, there is another method that you can use for division that's called synthetic division. Okay, notice it says on the notes you only want to use this method if the divisor is of the form x minus c. And that just means that your leading term of your variable, if it's a 1, then it's easier to use synthetic division rather than long division for these. Okay, so the example 2 we had up here would be one that would be a little bit more difficult to do by using synthetic division, so we usually stay away from using it with those types. Okay, but let's look at example 3 and how you would set up synthetic division. You would still want to make sure that the polynomial that you're dividing is in the correct order, which it is. And so I'm going to write down all of the coefficients, like the coefficient of x squared is a 1, the coefficient of x is 14, and then my constant is 48. Okay, so then I'm going to draw a box to the outside, skip some space underneath, and draw a line. Okay, what I'm dividing by here is of the form x minus c, so that means my c value would actually be negative 8, okay, since we said of the form x minus c. So in my words, I say we always change the sign of this number, so that would be negative 8. Then as far as the process, the first number is always brought down underneath, and then we start multiplying. 1 times negative 8 is negative 8. You either add or subtract here. It depends on what your signs are. Since they're different, I'm subtracting, which would be 6. Once I bring a number under this bar, then I'm going to multiply it. So 6 times negative 8 would be negative 48. And then again, this would be 0. The numbers across the bottom represent the coefficients of your answer. The last number is always going to be your remainder. So this means that there is no remainder for this problem. I need to go back now and plug in my x values. Whatever your highest degree is in your problem, your answer will be 1 less than that. So that means starting with this 1, it would be 1x plus 6. You always have a constant that doesn't have a variable with it. So my answer, my quotient would just be x plus 6 with no remainder. Okay, let's look at number 4. Using synthetic division, we have x to the 4th plus 625 divided by x minus 5. Okay, when I list my coefficients, I have a 1 for x to the 4th. Okay, with all of your division problems, you can't skip a degree. So that means because I don't have an x cubed term, I have to put a 0 for that. So I'm putting a 0 for x cubed, a 0 for x squared, a 0 for x, and then my constant. So whatever your highest degree is, you have to have a place for every degree less than that. Okay, so then I'm dividing by, change the sign, that's going to be a positive 5. And then I start the process. Bring the first number down, so I'm bringing down the 1. Multiply 1 times 5 is 5. So 0 plus 5 would be 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. And then this would be, if we add these together, would be 1250. Okay, so now I need to go back and plug in my variables. The highest degree was x to the 4th, so I'm going to start, this would be 1x to the 3rd plus 5x to the 2nd plus 25x plus 125. I should always have a constant. Then I have a remainder. Remember we said this last number is the remainder. 1250 over x minus 5, which is what I was dividing by. So all of this would be my answer. Now if we did this one by long division, you would still get the same answer. It would just be a really long problem you would have to work out. Okay, so synthetic division is going to be useful in the next few problems that we're going to be working out. You're going to be using it a lot. in the next few sections.